Okay, so in the next part of this unit, I want to go and talk a little bit about writing your own code um, for use as a module. So, as I was just explaining, a Python module is just a file which contains Python code and has an extension .py. And as you work in bigger projects and bigger coding problems, you're going to be able to write your own modules. And more immediately, for all of the assignments, all the assessments you're doing for the vitals for level 2 coding, you're going to be submitting them as a module, as a .py file of your solution. So, as I said, all we have to go and do is create .py files, so plain Python code files with .py extension that contain the code. So, for example, here I'm going to make use of the code we've written in Unit 2 of this strand on structuring code, which is a Fibonacci sequence calculator. And what we want to do is we're going to put it in a file called Fibonacci.py, and this is the code that goes in there. Okay, so having done that and created that file, so if I go over to Spyder, here is my Spyder, and I've just created a file called Fibonacci.py, and it's got that function in it. For a description of how that function works and what's going on, go and watch Unit 2 of the code. And in order to go and use this, I just do import Fibonacci, like so. And I can do this in a program, or I can do it in my console here, whatever works best for me. So, there we imported it. And once we've imported it, we can now use that function that's defined inside it which works straightforwardly. This is just calculating the Fibonacci series up to a term which is no bigger than 1,000. And so that's great, that works. So that, in a sense, is all we have to go and do. That's defined a Python module and we're able to use it. If we want to look at what's inside a module, then we can use the dir function, and that will tell us what functions and variables are defined in our Fibonacci module. So if I do that, then I get an output that looks like this. And we can see at the end there is our Fibonacci n function that we were just using. And then there are a whole bunch of other things in there, all of which have names which start with double underscore. And one of the things to understand about Python is every time you see something with a double underscore, you want to be thinking, that's something a bit special to do with how Python actually works. It's a special variable or a special function that is involved in how Python's actually working underneath. So I'm going to show you what some of those are actually used for and why you might want to know about what they are. So the first question is, well, what happens if you had two module files with the same name? Well, as we said in the first part of this unit, Python is going to search sys.path, and as soon as it finds any file with the right name, it's going to try and work with that one. So any other module file with the same name that comes after that in sys.path will never get seen, it'll never get loaded. And again, this tells you need to be a bit careful with sys.path because you could, for example, create a file called numpy.py, put it in a directory near the start of the path, and now you won't be able to go and use the numpy package because you've written a module called numpy that presumably doesn't do the same thing. So you need to be a little bit careful. What you can do is, having loaded a module, you can say, well, where's this module come from? And in order to go and do that, you can look at the __ file __ special variable. So if I just look at Fibonacci dot __ file __, then on my laptop this is where it recorded. So it's the folder where I'm writing the this particular unit. When we import the module, you remember it says it gets added to sys.modules. It gets stored in sys.modules, and sys.modules is a dictionary, and the keys of the dictionary are the name of the module. So Python needs to work out what name that module is to be given. This is normally the same as the name of the file that you've loaded it from, but importantly note that's not necessarily the same as the name you're referring to the module in your code. So for example, you might import NumPy as NP. The name of the module is NumPy. The name you're referring to it by is the NP. We can see what name Python is using for a module by looking at the __ name __. I'm going to say dunder. Dunder is a bit of Python speak, which means double underscore. So we say dunder name, I mean __ name __. So if we look at that for the Fibonacci module, so Fibonacci.dunder name, it comes back and tells us it's called Fibonacci. That's not a surprise, it's been loaded from Fibonacci.py, so that's why it's got that name. But as I said, if we import the name with an alias, the name that is returned by dunder name remains the same as it always would do. So here's the example I was talking about before. I import numpy as np and then ask what's np.dunder name, and it comes back and it tells me it's numpy. So it doesn't matter if I import modules with different aliases, Python knows it's the same module. And so there's only ever one imported once, and only one of it lives in sys.modules. And you can test whether a module exists in sys.modules. This is just the same way as you test whether a key exists within a dictionary, because that's all we're doing. Sys.modules is just a dictionary. It's a dictionary whose keys are the names of the modules, and the values are the results of importing the module. So since I've imported NumPy, NumPy is in sys.modules, and so it returns true. The dunderdoc special variable will contain the module's docstring. So in the debugging unit 3 videos, I was talking about docstrings and how important docstrings are for helping you keep track of what your code is doing. So as well as having a docstring for a function, a module can have a docstring as well. There's less strong conventions about the formatting of a docstring for a module, but it's still useful for it to go and describe what the overall purpose of that module is. What functions does this module contain? Where are they being used for? Maybe a link to some documentation for it. So a docstring for a module is simply the first line of the string, a string on the first line of the module. So again, we can go over to our Python code, and here I've got another version of the Fibonacci code, and I've just put a string on the first line, and that's the docstring for the whole module. That's different from the docstring for the function. This is the docstring for the module on the first line here. So if I was to do that and then print Fibonacci.dunderdoc, then it'll print out that string that I've defined at the start of the file. And that's the same thing you get if you ask Python to query or to give you the information about the Fibonacci module. So again, one of the things you can do in Jupyter Notebooks, or if you're using the Python console in Spyder, is you can type the name. In fact, I think this even works in just straight Python. You can type the name of the thing you're interested in, put a question mark after it, hit return, and it will give you a little bit of information about that, whatever that is. So in this case, you can tells you it's a module. It tells you that it's been loaded in from the file it's been loaded in from, and it prints out the doc string as well. So it's kind of giving you some basic information. Of course, if the doc string was longer and more complete, then you'd have more information there. So again, if you're writing your own modules, it's a good idea to give it a nice doc string. So sometimes when we're writing our own module, we also can define our own Dunder special variables. These are only done by convention. There's no, although they've got a special double underscore, they're not really part of the innards of Python, but they're used to indicate that they're giving you what you might say is meta information about the module that you're working with. And so some of the common ones are, sometimes you might specify an author, and often you specify a version, and that can be useful because you might need to go and check if you know that a particular function was only defined in a certain version of a module. You might want to check that you've got the right version of the module before you start trying to go and call a function that may or may not exist. So indeed, if you go and do this on NumPy and look for numpy.__version__, then it comes back and tells you which version of NumPy you're using. Of course, that's going to depend exactly on how recent a version of Python you're using. So it may be version 2, maybe version 2.1, I think even version 2.2, might be version 1 point something. That doesn't really matter. But it's giving you information about the module.